So in the previous class we have learned topics which are actually related to the three-dimensional concepts, which are related to the AutoCAD. So for that one we have learned about what is the first angle projection, so what is the third angle projection, and what projections are actually being used and what projections are preferred based on the Bureau of Indian Standards, and what is meant by an isometric view. I've explained to you guys in detail about the isometric views. If you guys have any problems or any queries related to that one, you can ask me in the Google Classroom. You can post them. I'm happy to answer all of your questions. Okay, so let's start the session. In today's session we will going to see problems which are related to the projections of the planes, and we will talk about the solid editing commands that actually exist in the AutoCAD 3D basics. Okay. Today we'll talk about two problems which are related to the projections of the planes. Then after that we will see the editing commands which are related to the solids, the continuation of the previous class. Okay. The first problem that I want to take, I think there is a thin rectangular cardboard lamina as one of its corners on the HP. Rectangular plane lamina is there, which is actually resting on the HP by one of its corners. A rectangular lamina has 4 different corners here. Okay, 1, 2, 3, 4, and based on this one of these corners, it is actually resting on the horizontal plane, which means say that there is a horizontal plane and a vertical plane like this. Okay, if so, this particular rectangular plane is actually resting on horizontal plane by one of its corners, not on edges or not by surface. Okay, it is resting using one of the corners, and the surface makes (60°) with the horizontal plane. Draw its projections and the diagonal passing through the corner on HP is parallel to VP. The size of the lamina is 50 by 25 So let's see each and everything in detail here. After that, the surface of this particular rectangular plane lamina is actually making an inclination of 60° with the horizontal plane. Initially we were told that this particular so this particular lamina is actually resting on the one of the corners of the rectangular surface, and now we were told that this particular surface is actually making an inclination of 60° with the horizontal plane. Okay, so this one is initially, and still now it is on HP on one of its corners. Okay, and now the surface is actually making an inclination of 60 degrees with the vertical plane. Okay, so if you notice, since these two corners are not on the vertical plane, only one corner is on the vertical plane, means so horizontal plane means one corner is there on the horizontal plane, means this, this one is actually making a certain inclination. One of, any one of the edges are making certain inclination with the vertical plane. Okay, I'm sure we will talk about this one. So when the diagonal passing through that corner on HP is parallel to the VP. See here. So here it has two different diagonals. Okay, can you guys see? I've marked them with the red ink. Okay, it has two different diagonals. He's saying that the diagonal passing through that corner, the corner that is actually sitting on the HP, okay, the corner that is actually sitting on this HP, the diagonal which is passing through this corner is parallel to the vertical plane. Okay, so if you consider this one as the diagonal, this particular diagonal here is actually have to be parallel to the vertical plane. Okay, likewise we have to keep this edge in the horizontal plane, and we have to keep the surface at an inclination of 60 degrees with the horizontal plane. Okay, let me mark all the conditions here. So the first condition that was given to us is, as rectangular surface resting, not resting, as one of its corners on HP. Okay, so that's the first one. Now, second thing is the surface makes 60 degrees with the horizontal plane. Now the third condition is, when the diagonal passing through that corner is on HP is parallel to VP. Okay, so diagonal passing through the corner is actually parallel to VP. So I'm going to repeat the situation here so that you can understand this one. Okay, so here this is the rectangular plane lamina that is actually talking about. So the first condition that was given to us is there is no need to be, we have to take the first condition initially or the second condition in the second, third condition in the third place, not likewise, but whereas for this particular scenario we can take them. So rectangular surface has one of its corners on HP. So a rectangular plane lamina has 4 different corners. So one of the corners is actually resting on the horizontal plane. If we assume this hand as an horizontal plane, so one of the corners are actually resting on the horizontal plane. Okay. And what else was told? The surface makes 60 degrees with the HP. So if a corner is actually resting on horizontal plane, means the surface position can be anywhere, it is unpredictable. So that's why he has mentioned the angle of the surface. So this particular surface here is actually making an inclination of 60 degrees with the horizontal plane. Okay, so now this is making an inclination of 60 degrees with the horizontal plane, and when the corner is in HP, one of the corners is in HP, and the diagonal passing through the corner on HP parallel to the VP. So since this is the corner that we have chosen, okay, this is the corner that we have chosen, so this particular diagonal have to be parallel to the vertical plane. If a surface is like this, okay, this particular, initially we will keep this particular edge as it now parallel to the vertical plane, but whereas we want the diagonal to be parallel to the vertical plane, so we have to rotate this one in such a way that this diagonal and this vertical plane should be parallel. Okay, I'm going to do this in the AutoCAD. So once these two problems are done, I'm going to explain some basic procedure in order to do a problem that was actually related to these projections of planes. Okay, I'm going to the drafting. So here it's all about this diagonal. First, let me construct the rectangle that he is actually talking about. You guys will come to know why am I actually constructing this one initially without the XY. Let me take a dimension of 50, 50 and 25, right? Yes. And now 25, again 50, we have to construct the diagonals also. Now why do we actually need this? Let me draw the XY line now. Okay, so what is the first thing that we need to do? See here, a rectangular surface has one of its corners on HP. So we have chosen all these three conditions. So we might have thought that we can actually take these conditions, like we have to take initially this rectangular surface as one of its corners in HP. Actually, that's the situation that the the one who is giving the problem is explaining to us. Okay, these are the steps that this plane surface has to go through in order to get the final front view and final top view. But whereas initially we have to satisfy this condition 3 here. If you if you consider the previous examples also that I've given related to the projections of planes, so we have initially taken even though a certain plane is actually parallel to inclined to the horizontal plane, we have considered it parallel to the horizontal plane initially. So if a certain plane is actually inclined to the vertical plane, we have considered it initially parallel to the vertical plane, depending upon the scenario, whether you are getting a straight line in the front view or a straight line in the top view. So here, if we don't keep the diagonal parallel to the vertical plane right now, so once when you're trying to define this corner on HP, when you're trying to assume if you assume this particular corner as an example, this is assume that it is actually resting on the horizontal plane. If so, then you need to specify certain angle here, because if this particular edge is actually lying on HP, then there is no problem. You will get a rectangle here, complete rectangle here, which is whose two sides are parallel to the XY line. But whereas since one of the corners is actually resting on HP, you have to mention the angle made by this particular diagonal or this edge. Then only you will be able to progress or go to the next step in the problem. So once you're done with the third condition, then you can actually then obviously you're satisfying these two conditions. If you want to satisfy the condition 1 here, you have to satisfy the condition 3. Okay, and then we will go to the next step, which is the surface makes 60 degrees inclination with the horizontal plane, and then we will get the final projection, final top view and final front view, like this. So what am I actually saying here is, suppose if I keep the rectangle here like this, we were told that one of the corners is actually resting on HP, right? So right now, if you set the rectangular position like this, means you are actually doing what you are actually doing. You are actually trying to keeping this particular, which means these two corners are actually resting on HP, or these two corners may be resting on HP, we don't know. Okay, if you take the true dimensions, means it is completely resting on HP, which means all the four corners are resting on HP. We don't want that. We want one of the corners only to be in HP. If so, how does it actually going to look like? So what we are going to do now is, we will select this particular rectangle, okay, and we will first assume that this particular diagonal is parallel to the vertical plane and resting on the horizontal plane. Okay, clear? And then we will try to satisfy 2 and 1. If you satisfy the third condition, you can obviously satisfy the first condition. If you don't satisfy the third condition right now, then you won't be able to satisfy the first condition and second condition. So what I'm going to do is, I'm going to take a rectangle in such a way that, let me measure all the dimensions here. The problem might seems to be very simple, but whereas this one is somewhat complicated. Okay. You have to measure the angles also. 27. If this one is 27, obviously this one is going to be 27. You think you are learning mechanics, right? The dimension is 55.9. Inclination is 27. Okay. 60, 63. Hmm, 90 plus 27. 117. Wait. Now one is actually parallel, right? So now I'm keeping the diagonal parallel to the vertical plane. See here, this particular diagonal dimension 55.9. I'm keeping this one here. Okay, let me measure this one and show you this to you. 55.9. Now onto this column. Okay. 25, 27. Mm, 25, 63. I don't want to get an error, so that's the reason I'm doing this. Right now only this particular corner is actually resting. Okay, all the corners are actually right now resting on horizontal plane, but whereas after that we will going to tilt this surface, entire surface, about this particular point, so that this particular point will lie on the HP, and this diagonal is actually parallel to the vertical plane. Now let me give the namings. This one is here. I'm taking the projections here so that I'll tell you what is actually happening. Right now, the situation of this rectangular plane is it is actually resting on HP. I'm assuming the entire surface is actually resting on HP, and this diagonal is parallel to the vertical plane. Okay, right now only third condition is satisfied. Okay, so we can satisfy the first condition, and obviously after that we can satisfy the second condition. So from the front view, how does it actually going to look like to you? Like just a straight line, right? Only you can see a straight line. So here also you will going to see, since it is resting on horizontal plane, only you will be able to see this much of portion. Only this is the straight line that you are going to see in the front view. Now okay, so if you remember my the previous classes, I've told you, if you get a straight line in the front view, then consider the angle that particular plane is actually making with the horizontal plane initially. If you get a straight line in the top view, then consider the angle made by that particular surface with the vertical plane initially. Likewise, I've told you, right? So here we are getting obviously the straight line in the front view. So now we will going to make this particular straight line at an inclination which is equal to the angle made by the surface with the horizontal plane, so that we can get all the we can make sure that all the three conditions are getting satisfied, and that too we have to keep B dash on the horizontal plane. Remember, we have to satisfy these three conditions here. So first we have satisfied the third condition. Now since we will take this particular line dimension, obviously it is equal to the dimension of the diagonal, which is nothing but 55.9. if you want me to measure it again, I will measure it. 55.9. so now I'm going to draw a line of dimension 55.9 at an inclination of 60 degrees. Okay, I'm going to mark this one also as red so that you can understand. We don't know the locations of A and D yet, so we'll measure them eventually, no problem. Now see here, only B dash point is actually touching the XY line, which means that's the only point we are keeping in the horizontal plane. That's the only point which is going to sit in the horizontal plane. So that is what we actually wanted, right? So the first condition now is satisfied. So initially we have satisfied the third condition, now the first condition we need to, and since this particular one is at an inclination of 60 degrees, the second condition is also satisfied. Okay, if we don't take the angle at of 60 degrees, then we are not satisfying the second condition. Since we have taken that one, now we have satisfied all these three conditions. So whatever the projections that we are going to get now are going to be the actual projections that we require. Okay, this is how this rectangular surface is going to look like from the front view when its diagonal is parallel to the vertical plane and one of the corners is in horizontal plane. This is how it is going to look like. And how does it going to look like from the top view, we will see. In order to do so, we need to measure this line dimension, the distance between B dash and A dash. .35. Obviously these two should be equal. Correct. I need to draw another line. Now we need to mark if you want to give a different name you can give, but whereas I'm gonna stick with these points. Okay, now what we're going to do, we just have to draw the projections. So we don't need these smaller lines anymore. So draw the horizontal projections. On this particular same line, C and B will be there. Okay. So wherever this A dash and A are going to meet, that's the location where let us give the name A1. A1 is going to be, and now similarly wherever B and B dash are going to meet, I will name it as B1. Now similarly D and D dash are going to meet here. I'm going to name this one, name this one as D1. And lastly C. Okay. Wait a minute, guys. So this is how it will look like from the top view. Okay, now see here, the corner B1 is actually in the horizontal plane, and the surface is making an inclination of 60 degrees with the horizontal plane. And lastly, the diagonal, see here, B1 C1 is a diagonal which is actually, let me give a different color to this one. The diagonal B1 C1 is parallel to the vertical plane. So all the three conditions are satisfied. So this is how we do, solve these kind of problems. So I'm going to the next problem. A thin hexagonal plate of side 30 mm is lying on vertical plane. On one of its corners. Draw its projections when the surface makes 45 degrees with the vertical plane. So assume that a hexagonal plate will be having 6 sides. So let me convert this one. Okay, if you consider this hexagonal plate here, which is of sides 30 mm, is lying on the vertical plane, which means a hexagonal plate of side 30 mm. See here, each side of this hexagonal plate is 30 mm, and this particular surface is actually lying on the vertical plane on one of its corners. It could be anything, it could be any one of the corners. Draw its projections when the surface makes 45 degrees with the vertical plane. So here he wants us to draw the projections when this particular hexagonal plate is actually making an inclination of 45 degrees with the vertical plane and having one of the corners. See here, if a plane like this is having an inclination 45 degrees with the vertical plane, means the inclination would be somewhat like this. Okay, so let's go to the AutoCAD. 60. So this will be 30. Let's check the arcs. So this is the hexagon that is actually talking about. Right now, see, all the problems that I've taken today are somewhat related to the corners. Okay. So assume that this is the hexagonal that we actually need. So what actually was given in the problem is a thin hexagonal plate of side 30 mm is lying on VP. This particular plane is lying on VP on one of its corners. See here, if I take the hexagonal surface like this, am I actually keeping only one corner on VP? Since, see, this surface has to make an inclination of 45 degrees with the vertical plane, right? So when it is about to do, if you observe these 2 points here, these two points will lie on this particular vertical plane. We don't want that. We want only one point to be lying on the vertical plane. So we have to keep in this position so that we can make an inclination of 45 degrees with the vertical plane. So select this one, rotate this one by and actually center one have to be taken by 90 degrees. Yeah. Okay, right now this is the position that I actually require, since I want to keep only one corner on the in the vertical plane. So from the top view, you will be able to see only both are lying on the same plane, right? Okay, now see here. So since even though it is making an inclination of 45 degrees with the vertical plane, I told you, assume that this one is actually making 0 degrees with that particular plane initially. Okay. So let's give the markings to now. The A corner will be Since this is the front view, I have to mark so on this particular location A will be there. On this particular location B, comma F will be there. At this particular location C, comma E will be there, and at this location only D will be there. Okay, now what? So mark the conditions. Only two conditions were given to us. First condition is one of its corners lying on VP and the surface makes 45 degrees. It's the vertical plane. So these two are the only conditions that were given to us. Might seems to be a simple problem, but you have to be careful while you're drawing the geometry, because if you draw the geometry like I've drawn earlier, because obviously hexagonal means everybody used to draw like that. So I just want to remind you guys, I just want you guys to remember that how to have to rotate the geometry, create the geometry by for the depending upon the given problem. So that's the reason why I drawn that initially like that. So let's measure the line dimension 60. Yeah, this is 60. Now since the surface makes 45 degrees with the vertical plane, now initially it is like this, it is like this. Now we want the surface to make an inclination of 45 degrees. So from the top view it will just look like a straight line to you, right? So that's why we will going to draw a straight line. Line dimension have to be 60 and inclination have to be 45, and we have to mark the points also. So let me find these dimensions. 15, obviously. So let's draw the line 15. Similarly from this particular end, let me E1. This is fine, but okay is also fine. I've taken the same line. So obviously, since all the conditions are satisfied, let's draw the projections. B and C are going to lie on the same straight line. A and D are going to lie on the same straight line. E and F are going to lie on the same straight line. So wherever A dash and A are going to intersect, let's mark this one as A1, and wherever B's projections are going to intersect, this one as P1. Let me connect these two. Now, so wherever C and C dash projection are going to meet here, and D and D dash projection are going to meet here, and E's projection is going to meet here, F's projection is meeting here. So if I just complete the loop, so let's give the markings. C1, D1, F1, okay. So here initially you guys can actually see this, see the hexagonal plane like this, right? Since it is inclined at an inclination of 45 degrees to the vertical plane, so whatever the front view that you are actually seeing here, so it is this pink one. Okay, see here the dimension got changed, reduced, this dimension got reduced, and this is the reduced dimension is this pink one. Initially, if a plane is like this is the dimension and this is the geometry that you are going to see, but since it is inclined at an inclination of 45 degrees, so this is the geometry that you are going to see. Okay, and this particular corner is actually resting on vertical plane. So now we'll go to the AutoCAD. Go to the 3D basics. So in the previous class I've told you about these extrude, revolve, lock and sweep commands in deeply, but today we will going to see union, subtract. These are solid editing commands, by the way. So chamfer, fillet, and likewise there are certain tools are there, so I'm going to explain all of them. Let me take a box here. So why can't we take cylinders? Okay, this one is actually in 2D wireframe. Okay, so let me go to the shaded with edges mode. I've drawn the two cylinders like this. See here, I can actually select them individually right now. Okay, so union command is going to make two different objects as one. It is going to make two different, make the objects as a single one. So right now let us select these two objects and see what's going to happen. Okay, select the objects. Now see here, I won't be able to select them individually because both of them got unioned or combined. Okay, this name actually implies combined two. Okay, it's going to combine two different solids. Next one is the subtract. See, subtract works in a different way. It's just like subtracting that we actually use in the mathematics. So what is it actually going to do is it is going to subtract one particular portion of body which is actually inside of another particular body. See here, first I need to select the object in such a way that the object that you are going to select initially is going to be there in the AutoCAD, and the second one, okay, the object that you're going to select in the later stage or second stage, it's going to be removed from the first object. Okay, initially didn't work, right now it has worked. See here, can you guys see that? So actually what happened was, since I've selected this particular object initially, let me go to the X-ray mode. So there is a portion, so let us call this one as the first object and this one as the second object. So there is a portion of, or there is a volume of second object which is actually inside of this first object. Okay, so here, so whatever the portion of the second object that is there inside of the first one is going to be subtracted from the first one. Okay, clear? So if I select this one initially, so whatever the portion that is actually belong to the first one will be subtracted from the second one, and the second one is obviously eliminated. Okay, and this command has to be used in a different way compared to that of this union command. If it is just a union command, sorry for that. If it is just a union command, you can just select the objects and then just press enter. Okay. You can just select these two objects and press enter. What's happening? Yeah, both of these objects got combined. Okay, so that is what union is going to does. You can select both of them at a time. See here, immediately when I'm trying to give the command, selected the first one and second one at the same time, and then just press enter in order to combine these two objects. But whereas subtract has to be used in different way. So whatever the object that you are going to select initially will be kept, and whatever the object that you're seeing right now, I've selected the first one, press enter. Right now I've selected the second one. So now, so whatever the portion of second object that is there inside of the first one is going to be removed or subtracted from the first one. Okay, so this is how it is going to work, the subtract command. So let's talk about the intersect command. So the name itself actually indicates it is going to take something common which is related to two different objects. So there may be situations okay, so there are situations when this particular command has to be used in order to get some different shapes. So when you use these subtract, union and intersect commands, you can get some of the shapes very easily. Okay, it will be very much easier for you to get some different shapes here. So I'm going to explain about the applications and these objects later in detail, applications of these objects, so that you can understand what I'm actually saying about. But since there are a lot of tools which are related to the solid editing, so for right now I'm going to explain about the concept that is behind these editing commands. Okay, so intersect means it is going to take the combined portion. Okay, union means it is going to combine both of these. Subtract means it is going to subtract one object from the another object. Intersect means it is going to take the common portion. So this is the first one and this is the second one. We can select them at a time. Okay, so this is how an intersect command is going to work. You don't need to you don't need to select them individually, but you can select them at a time and then just press enter. Only for the case of subtract command only you have to select these only for the subtract command only you have to select them individually and then press enter. Select the first object, press enter, select the second object, press enter. But whereas for union and intersect, you can select them at a time and then just press union. Okay, likewise it is going to work. So let's talk about the remaining tools also. There are tools. Fillet edge. Let me take a rectangle here, cuboid shape, so that it is easier for you to understand. Fillet edge. See, we have fillet in the drafting and annotation also, but that one is different. I have to mention the radius, say 0.5. This is fillet. The three-dimensional fillet means this particular radius is there, right? That radius will be given throughout the thickness. See here. I have selected the edge. Now we need to mention the radius, say 0.5. Okay. Unlike these previous cases, you have to select, you have to press enter twice in order to get out of that particular command. Okay, it is going to work in that way. And the next one is the chamfer. I'll show you guys the difference between these two once again. fillet is going to be created like this. It's going to create this particular radius at the edge, and it is going to be given throughout that thickness. So whatever the object that is there, which is having certain thickness here, so throughout this thickness, throughout this T, this radius will be given. But whereas for the case of chamfer, you will be provided with sharper edges here. There is a reason why I want to draw these figures. See, so whenever you want to use the chamfer command, it is asking for select an edge. Make sure the dynamic input option is on, because if it is not there, then you're going to miss a lot of information. Press D, enter, and then give dimension of 0.5. okay, see here, this has not taken the dimension in this way here. Okay, you have to give two different dimensions. So that one should also be 0.5. I told you to enter twice in order to get out of that command, and if you want to see the output of whatever the command that you have used. See here, can you guys see this one? So here, what is this distance D1 and what is this distance D2? So this is the actually choose like, but for our convenience, let us say this is D1, distance 1, and this is D2. Sometimes the chamfer need not to be equal. Okay, there is a reason why we actually use this chamfer and fillets in order to avoid the stress concentrations. This one is fillet and this one is chamfer. Okay, let me go to the next commands. I'm repeating once again, you have to hit twice, enter twice, otherwise you won't be able to get out of that command. So select the edge, give the dimension. Actually, since the dimension was already mentioned, it has taken, you have to press enter twice, then only you will get out of the command. Now let's go to the extract edge command. I'll tell you guys the application of this one later, but for right now, just see what does it actually going to do. May seems to be nothing was happened, but let me move the actual object so that you can see. So can you guys actually see that it has extracted the edges from this particular solid? Okay, there is a reason why there is an application for this particular tool. I'm not going to talk about the application of this one right now. Okay, now the next one is the slice tool. Slice. Okay, let's talk about the slice command now. Click on this 3D slice tool. Now select the object, specify two different points and then just press enter. Okay, so now you have sliced this object into two different parts. Okay, so this is how you can actually slice objects here. I think when you use this extrude faces, extrude edges extract edges command, use that one. I think it's still there. So let's move to the next one. This one is about surfaces, thickening a certain surface. So I'm not going to talk about this one. So taper faces, which whenever you want to make a certain face a taper one, so select the face, and then press enter. Specify the base point. About this particular base point alone there will be inclination. Okay, say taper angle say 45 degrees. If so, it will be, I told you have to press enter twice in order to get out of that command. Let me erase this. Okay, so if you give negative inclination, a negative, the taper will come on this side. So let me explain this one. Since the extract edges are there, so I don't want that to create confusion to you guys. Okay, let me select this one. Select the face that you actually want to create taper. Specify the base point, say negative angle, say something like some minus 20 degrees. So the face will be created to the front. So there are lots of different options are there. I'll talk about some of the important ones later, not in this class. So press enter twice, okay, to get out of that command. So initially I have given positive angle, so the face was got inclined or it went inside of the object. Now since I've given negative angle here, it has came out of the object. Okay, now the next one is the extrude faces on. This one is actually somewhat similar to the extrude option that we have here. What is it actually going to do? It is just, if we select a particular edge here, we can give the extrusion height, say, if you want the taper, you can include the taper too. To get out of the command, press enter twice. You have just extruded this face. Yeah, extrusion height, say something like some 0. Let's say 2, and then just press enter. Okay, can you guys see that? Likewise, we can extrude the faces. And there is one more option that you guys need to know, which is obviously the taper angle that you want to include. Say 15. If you include the taper angle also, the face will be extruded like this with that the taper angle that you have specified. From that base point, keeping the face as the base point, it will start extruding that particular face. See here, the angle made by this horizontal line and this extruded face here has an inclination of 50 degrees. Okay, depending upon, if you want that to be the taper to be on the outside, then provide the negative angle. If you want to, whenever you want to increase the volume and whenever you want to widen that particular face taper, then go for the negative angle so that you will get them. Okay, the next command is offset faces. Offset faces works for us in order to increase the we can extrude the faces using the offset command also. Okay, and not only for that, we can mostly, I think it is used for enlarging the holes or shrinking the holes. Say that you have made a small plate with some a number of holes on it, but the dimensions of the holes that you have actually provided are not just enough. So what you can do now is you can go to this command here, offset faces, and then select the faces which are interior to the holes or inside of the holes. Select the surface inside of the holes and then provide the offset as you want to. If you give negative offset, it is going to enlarge the hole or decrease the hole. Likewise, there are we can use the offset command in that way. So to explain that one, I am going to take a small circle here. I'm going to take a small circle. Okay, so using the press tool, we can actually create holes also. I've told you that in the beginning class. Let me show you guys how to do the extrude, how to create the holes using the extrude command and subtract command, since we have talked about this one. So the object that I want to keep has to be selected first. Press enter, and object that I don't want to be or subtracted has to be selected in the second stage. Okay, can you guys see I have made a hole here. Suppose if I want to enlarge this hole, selecting. Okay, so we can select an offset distance of say 0.2. Can you guys see that it has, since I've given a positive value, the dimension of the hole got decreased. Suppose if I want to increase the dimension of this particular hole, select this face, a dimension of 0.4. Okay, this is how you can use the offset command. Okay, that's it for today. I'll see you guys in the next class. Okay, post your doubts in the comment section. Otherwise, you can post the whatever the doubts that you have in the comments in the Google Classroom also. So today we have learned about uh, the different solid editing commands in the AutoCAD, and we have learned about two different cases. We have seen cases where the planes in having one of the corners sitting on either an horizontal plane or vertical plane. If so, then how to solve the problems which are actually related to them. Okay, do not forget to post these topics that you really want to learn. So up until now I've covered the second unit entirely. But still, if you have any issues or any doubts, you can post them in the comment section. Okay, otherwise you can post them also in the Google Classroom. So if you have any doubts related to projections of points, projections of planes, or projections of straight lines, you can post them. Okay, I will repeat those particular topics. If you want me to repeat any topic, you can ask me. You can post it in the comment section. Okay, I'm very much happy to answer all of your questions. Okay, so if you guys don't, I'm going to select a few more complicated problems from the second unit, and after that I'm going to start the third unit. Okay.